Okay, so we're going to see how to physically use the Raspberry Pi. As you can see out here, so I have my Raspberry Pi and I have my breadboard and my Raspberry Pi. These are the pins of my Raspberry Pi, the 40 pins that I told you. This is pin number 1. This is pin number 1 over here. This is pin number 2 on the other side. Pin number 3, pin number 4, pin number 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. This is 39, and the last one is 40 on the outer side. Okay, so 40 comes here, and 39 comes here. All right. Of course, I should not be able to, even though if you don't understand how the breadboard works out. By the way, the breadboard is nothing but it helps you to connect circuits. Okay, it helps you to connect circuits in such a way. Let's say, for example, these 5 pins, you can see there are 5 holes out here, right? These 5 holes, then there are 5 holes next to it. These are vertical holes. And as you can see, these are horizontal holes. So you have a list of horizontal holes and you have vertical holes. Again, horizontal, horizontal, vertical. Okay. So now, whenever you see vertical holes, these are interconnected to each other electrically inside. Okay, inside they are, this entire thing is actually one copper strip, right? So that each of them are connected to each other. Each of them are shorted to each other. Okay, they are connected to each other. So that means if you use this one pin, if you use this one hole, it is equivalent to using this hole, right? They are connected to each other. So this is just helps you to create your circuit. So say, for example, you want to tap one particular line. You want to tap a particular line at you want multiple points of tapping a particular line. Then you use, if it is for this particular line out here, then you can use all the vertical holes one after the other. So that's how we use the breadboard. Okay. Hope that is very clearly understood. Then of course, we have an LED that's out here. So this is your LED, which can be used anytime. And your LED is something which, again, it has two legs. Okay, the LED has 2 legs. Okay, one is the longer leg, as you can see, if you can just bring them together. One is the longer leg, which is the anode, and second one is the shorter leg, which is the cathode. Okay, so the anode and the cathode. So the anode needs to be given a positive voltage with respect to the cathode. The anode needs to be given a positive voltage with respect to the cathode, and if the anode is given a more positive voltage with respect to the cathode, you will get you can get more kind of what do you say? You will get the LED to light up, because the LED will become forward biased, and then you can light that up. All right, let's just do it rather than a lot of theory now. Connect the LED. Two of these legs, each of them, we're going to connect them to 2 different lines on the breadboard. Okay. Remember, don't connect them on the same vertical line. Connect them differently on 2 different lines of the breadboard. They are not connected vertically. They are connected, as you can see out here. One leg of the LED is here, and the another leg of the LED is here. So they are on 2 different vertical lines, because if you connect on the same vertical lines, both the legs of the LED will get shorted with each other. Now they both are not connected to each other, right? This line of the LED is not connected to this line of the LED, right? Why? Because they both are on 2 different vertical lines. If they were on the same vertical line, they both would get connected, and it's not very good if you would do that. All right, so that's your LED, and if you want to just make a connection, you can just connect, because it is a 3.3 volt. You can afford to use the LED without using any protection, like a resistance or something like that, right? So let me just take 2 wires. Let me take 2 wires right now, and let me take a red wire. I'm going to insert the red wire into the breadboard at the same line, in the same vertical line as the anode. So as I told you, if I want to tap the LED at, okay, so anode is on my anode is here to the right and cathode is here. Okay, so I'll just connect the red wire to the anode, and of course I need to use a wire which has two different kind of endings. Can you see the ending which is there on this side of the wire? It doesn't have any metal. You can, it has a hole such a way that you can insert it into the pin of the Raspberry Pi. Okay, it has a hole. So this particular end is called as a female end of the wire. And this particular end of the wire, as you can see, is a metal end, which is a male end of the wire, which you can insert it into the breadboard. And I'll just connect it to 3.3 volt. As you remember, 3.3 volt is the first pin of the Raspberry Pi, pin number 1. And I'll connect a ground. The ground is pin number 6. As we had seen this thing, ground was pin number 6. So I can connect pin number 6 for now. And pin number 6, I'll connect it. Oh, just give me a second. Yeah, pin number 6 is then going to be connected to... Alright, I think you need to give some resistance, else this is already blown up. Just a second. I'll just give a small resistance out there. The LED cannot work without a resistance. I'll just give small resistance, just a second. I'll just, here we have, so let me take a small, okay, connected wire resistance. Let me check if it has blown up already, else we'll connect another LED. Okay, so here we have red, and this is your ground. Okay, so connected always via resistance. Thankfully it's not blown up. Okay, so a resistance, why is a resistance needed across an LED? A resistance is needed across an LED because an LED is a low resistance device, which means it can, if current passes through it, it's a very low resistance, it will burn out. Hence, you require in the path of the circuitry, you require some sort of resistance which you need to provide. So when you give the high volt, that is a 3.3 volt, you give it to the anode of the LED. The ground of the LED, I'm not going to directly connect to the cathode, but I'm going to connect it to one end of the resistance. The other end of the resistance is then given to, the other end of the resistance is connected on the same vertical line. The other end of the resistance is connected on the same, see, can you see the other end of the resistance out here? Okay, so the resistance has two ends, one is here and one is here. The other end of the resistance is connected on the same vertical line as the cathode of the LED. So the cathode of the LED is connected on the same vertical line as the resistance, and the resistance from this end, this is connected to ground. Hope that is very clear, right? So my LED is on for now, okay? I haven't programmed it. I have just made it on by giving a high voltage. Now comes a question, sir, I want to blink my LED. I want to make my LED go on, off, on, off, on, off. I want to continuously blink my LED. Now, one of the stupid things that you can think of is where you can just take this, I can take off this plus 3.3 volt, and I can just touch the leg, bring it out, touch the leg, bring it out. Basically, what am I doing? So I'm kind of blinking the LED, but what am I doing? I'm doing it electrically for now, but it's something very foolish. What is it foolishly done? What am I foolishly doing? I am basically giving a plus 5 or a plus 3. I'm giving a plus 3. I'm giving a high voltage to the anode. Then I'm removing it, which means I'm giving a 0 to the anode. Then again I'm giving a 5 volt to the anode. Then again I'm removing it. Again I'm giving a high. Then I'm giving a low, a high, a low, a high, a low, a high, low. Which means I need to do this programmatically rather than doing it electrically. I cannot keep doing this all the time. So how will I do it programmatically? I need to connect my anode of the LED. Instead of connecting it to a high voltage all the time, that is high voltage meaning a 3.3 volt, instead of connecting it to a 3.3 volt, I will now connect it to a GPIO pin, a general purpose input output pin. So I'll take it out from the 3.3, that is the first pin, and I will connect it to, let's say, the pin number 3. Where is pin number 3? Can you see pin number 3? So if I just raise this up a bit, you can have a look. Okay, so I have connected, so this is pin number 1. As you can see, this is pin number 1, this is pin number 2. Okay, and this is pin number 3. Pin number 3 I have connected it to. Now using pin number 3, I'm going to give it to the anode. Alright, now I need to program my pin number 3 to give a high, to give a low, to give a high, to give a low, such that my LED will start blinking. So I need to do that. So let's do the programming part of it, and then we are going to see the output. Okay, hope you're ready. Let's start.